Hey guys, how you're doing? In today's video we are gonna see some limits. We are gonna deep dive into this expression and see what does it mean, and I'll show you some basic exercise on limit evaluation. This one is gonna be the first video of a series, so we're gonna be just doing some really basic limits, and we are gonna do more difficult one in the next couple of videos. So grab your pen and paper and I will see you in a minute. So guys, the first limit I want to do with you is a graphic one. We have h of x, which is plotted in this way, and it has a little hole when x is equal to 2, which means that the function h of x is not defined when x is equal to 2. But despite that, we can still compute the limit as x approaches 2 of h of x in the following way. So you can notice that as we get closer to 2, both from the right hand side and the left hand side, the function h of x is approaching the value -1. Indeed, if I keep drawing here, I would end up exactly at -1, and doesn't matter if I do it from the right or from the left, I'm gonna always end up there. Which means that the limit as x goes to 2 of the function h of x is exactly equal to -1. Perfect, we have done this graphic limit. Let's go on with an algebraic one. So the second exercise I want to show you is the following limit. The limit as x goes to 3 as x squared minus 9 divided by x minus 3. So the first things you always do when you have to compute a limit of this form is to insert the value that you are taking the limit to. In this case, 3. So what we are going to do, we are going to put 3 in place of x as a first step. If we do it, then we get 3 squared is 9 minus 9 divided by 3 minus 3, which is equal to 0 over 0. So now this 0 over 0 is an indeterminate form. Why is that? Because 0 divided by any number should be 0, and in general we are not allowed to divide by 0. So the combo of these two makes us wonder what's gonna be 0 over 0. It can be literally wherever, and it's a situation that you have really take care of using the property of the limit. So after that you say, okay, I got a 0 over 0. It's gonna be a general and hard situation to solve, but not in this case. Why is that? Because we notice that x squared minus 9 is just x minus 3 times x plus 3. Indeed, x squared is the square of x, and 9 is just the square of 3, and I'm taking the difference of the two. And we know that this can be written as the product of the first term minus the second one times the sum of the two. Perfect. So now when we divide on both sides by x minus 3, we can simplify x minus 3, and this one becomes just x plus 3. So now we are going to use this expression inside our limit. So we can rewrite the limit as x goes to 3 of x squared minus 9 divided by x minus 3. This is equal to the limit as x goes to 3. We've seen previously that x squared minus 9 divided by x minus 3 is just x plus 3. So this is going to be just x plus 3. And now we can just insert the value 3 inside of x, and we get 3 plus 3, which is 6. That's it, and that's how we solve this other limit. Let's go on with a third exercise. So now it's time to talk about directional limit. What I mean by that? Well, whenever I consider a number, so I limit to a specific number. In this case, we're going to consider a limit as x goes to 2 plus or minus of h of x. Well, there are two ways of approaching this number. One way is staying on its right hand side, which means that I pick values of x that are approaching 2, but all these values of x are bigger than 2. So I'm going to 2 on the left hand side. But I can also do the same things by going from the left hand side. So I'm gonna pick up values of x that are always less than 2 in this case, okay? How do we make any difference between these two limits? Well, we are gonna say that when we approach from the right hand side, so from value bigger than 2, we are gonna approach 2 plus, so like this. And whenever we are gonna approach 2 from the bottom, so from the left hand side, we are gonna get 2 minus, okay? This is the only difference. And now you see that graphically this function is discontinuous at x equal to 2, which means it has this jump, right? So on the left hand side is going like a straight line, and then there is a hole when x is equal to 2, and when it's equal to 2 it jumps down to 0, okay? And now how can we tell the difference between these two limits, 2 plus and 2 minus? Well, to compute the limit as 2 plus, what we have to do is say, okay, now we are gonna fix x to be slightly bigger than 2. What's the value of the function now? Well, I go up, the value of this function goes here, and as I'm approaching and getting closer, well, the value of the function is going to approach 0. So that's what just I'm gonna write. So as I'm getting closer to 2, from the right hand side, I get this to be equal to 0. Now let's do the same things from the left hand side. So I'm gonna get close to 2, and when I do jump, well, I jump here with the value of the function. And as I'm getting closer, I'm approaching the point 2, 3, this point here, which means that the limit as h of x, as x goes to 2 minus of h of x is equal to 3. Now these two numbers are different, right? These two limits are different, and this tells me that in general the limit as x goes to 2 of h of x is undefined, does not exist. Why? Because in order for this limit as x goes to 2 of h of x to exist, both the right limit and the left limit have to be equal. And instead, in this case, they are different, so the limit is not defined. Okay? Perfect. Now we're gonna face the same kind of situation, but algebraically. So without a graph, we are gonna do it by hands. See you in a sec. So for the final exercise of the day, I have this one for you. I want you could consider the function h of x to be equal to 3x plus 4 when x is bigger than 1, and 1 plus x when x is less than 1. This h of x is a so-called piecewise function, which means that it's defined for some interval, okay? So it's defined only for some x bigger than something, then we have to consider this value, and when x is less than 1, we have to consider this function here, okay? So it's defined on some intervals. And now I'm asking you, well, compute the value of h at 1, compute the limit at when x goes to 1 plus of h of x, the limit as x goes to 1 minus of h of x, and the limit as x goes to 1 of h of x. Okay, let's start from the evaluation of the function. So h of 1 equal. Well, when x is equal to 1, what do I have to do? So x is 1. So first things, I'm gonna look where the function is defined. And here I see that x is bigger than equal than 1, then the value of the function is 3x plus 4, which means that 1 is in this domain. So I have to just substitute x in this first line, x equal to 1 in this first line. And when I do that, I get 3 times 1, so 3 plus 4, which is 7. And this is the value of my function. Second, I want you to compute the limit as x goes to 1 plus of h of x. So let's first look at the limit and try to understand what it's asking. It's asking what's the value of h of x as x approaches 1 from the right hand side. So now x, we have to think that is bigger than equal than 1. So it's bigger, sorry, than 1. Okay? So how I do that? Well, I go back to the definition of the function, and if x is bigger than 1, well, I'm here. I'm in this domain again, which means that for all value of x bigger than 1, this is the expression I have to consider. And now we can do the same as before and just try to plug into the value x equal to 1 in this expression, and I get again 3 plus 4, which is 7. And since 7 is a good number, I can just keep it there. Now, let's try to compute the limit as x goes to 1 minus now of h of x equal. Now the situation is a bit different because I'm taking the limit as x goes to 1 minus, which means that x we have to think to be less than 1. And when x is less than 1, well, now the expression I have to consider is not anymore the first one, which is valid only for x bigger than equal than 1, so this goes away, but we have to consider the second expression because we are in this domain. Great, so for x less than 1, the value of the function h of x is 1 plus x, so I'm just gonna plug x equal to 1 in the second expression, and I get 1 plus 1, which is 2. And now for the final question, I get that the limit as x goes to 1 of h of x equal to what? Well, now I computed both the right limit and the left limit, and their value is different. This means that the limit as x goes to 1, full stop, so no plus nor minus, just to 1, is not defined. Because the right and left limit are different. Perfect. That's all I have for you for today. I'm gonna see you in the next video, and we're gonna do more limits, a bit more complicated than this one. See you next time. Enjoy!